Today's video is all about Team Blue. The B360 Gaming Plus from MSI. B360, it's not unusual that we look at, sort of the other chipsets, Z370 or die, right? Or Z390, Z390's getting ready to come out. But I don't think that's actually like, Intel has got the market segmentation game down. So, the segmentation of the segmentation of the segmentation is the B360 and the H370 chipset. So I've got an Intel 8700, fresh from Micro Center. It still smells like Micro Center. So, yeah, yay Micro Center, I don't know, whatever. Also got the 970 Evo. We're gonna put that in here. The B360's got a single M.2, so it's exciting. Let's get into it. But first, well, no, let's roll the intro and then we got a lot to talk about. So I always try to do motherboard reviews, not as motherboard reviews, but like, so you could learn something, because it's not just about the chipsets. I mean, I figure that you're watching this video because you're just interested in the technology, or maybe you're looking at buying the B360 Gaming Plus motherboard. Spoiler alert, it's a pretty good board. It doesn't do some stuff, it does some other stuff. There are other boards that you can get that'll do the stuff that it doesn't do, but I'm getting ahead of myself. B360, who would want it? Basically anybody that doesn't want to overclock. So yeah, Intel CPUs, in case you're not in the know, the CPUs that ended the letter K are what is said to be multiplier unlocked. They're overclockable. Some people might say that you need the K series CPUs to do any overclocking, but that's not actually true. Really what's happened is Intel has segmented the overclockability of their parts. So like they've got the extreme high end of like the overclockable, and then they've got like somewhat overclockable, and then there's everything else, which is just everything is completely locked down. And I would bet, because they still haven't really, like the thermal paste is not really that good in the overclockable parts. And so like you could overclock the 8700K, the overclockable version of the CPU that I have, more than most people. Most people are typically able to hit 4.8, 4.9 gigahertz as an all-core overclock in the 8700K. Some people, it's a little bit of a debate in terms of how many people are able to hit 5.0, 5.1, 5.2, 5.3 gigahertz. Those are more unicorn overclocks. You typically will see those with insanely high-end coolers. And also people are dumping hundreds of watts into a CPU that's, rating is like 95 watts, or in this case, 65 watts, 65 watt rating on this i7 8700. So what does all this have to do with the chipset, man? I don't really care. Well, if you're not gonna do that extreme overclocking on the K part, then obviously the board doesn't need to have that kind of crazy power delivery. I mean, you don't wanna build, if you're gonna put a V8 engine in a golf cart, it doesn't really track, it doesn't really hold up like that. So you gotta build a frame that's appropriate for the motor. And so even though these are not quote unquote overclockable, you can still get somewhat of an overclock. So for example, 4.3 gigahertz, all cores, all 6 cores, no problem. But you look at it and it's like, wait, the base clock is 3.2 gigahertz. Well, let's side by side from Intel Arc, the 8700K and the 8700. And you look at it, it's the 8700K, 95 watt TDP thermal design power. Although I'll tell you right now, that's a lie. 8700K is gonna use a lot more than 95 watts especially when you're doing that 4.7 gigahertz turbo, especially if your board and settings are encouraging that to happen on all your cores. It might be 95 watts with like 1 or 2 cores running 4.7 gigahertz, but come on Intel, come on. Similarly, that 65 watts with this, 65 watts is about what you'd get with the base clock of 3.2 gigahertz. So you talk about the clocks, and you look at the 8700 and the 8700K on Intel Arc, and you're side-by-siding this, and you're like, wow, the 8700 is 3.2 gigahertz, the 8700K is 3.7. That's a 500 megahertz difference. That's pretty big. Yes, I would agree, that is pretty big. The reality is, though, that with this 8700, you will not see that 3.2 gigahertz base clock unless you're doing something wrong. You'll see it, I think, on OEM systems like Dell or HP systems that are just like rank and file business class desktops, I think you would see the 3.2 gigahertz base clock there. But even with a B360, even with lower end boards than this, you're not really gonna see a 3.2 gigahertz base clock ever. I can tell you right now, because I've already put together a few systems based on these, just for friends and that kind of stuff, finally getting around to making a video on it. The 8700, 4.3 gigahertz, all core overclock all day long. We even saw that on the little mini PC, the 4.3 gigahertz all day long, with its constraints living inside a tiny little mini PC. Another thing that most people do not realize about the B360 chipset is it's actually newer silicon than Z370. Z370 is just a revamp of Z390 to get Coffee Lake out the door, to have 6 cores on the desktop, to respond to competition in the marketplace, I would say. So Intel is working on a replacement Z series chipset, Z390, that's gonna have the features of the H370 and B360 chipsets. Yeah, B360 and H370 are actually newer, better silicon than the Z370. Who knew? It's a thing. Yeah, I mean, doesn't that seem crazy? So one of the big differences is it's got built-in USB 3.1 Gen 2, the B360 and H370 chipset. How many ports you get? A little bit less on B360, a little bit more on H370. Also built-in wireless. It's called CNVI wireless, and basically Intel's moving a lot of the network bits of the wireless network card actually onto the CPU, the way that they have with the wired Ethernet interfaces for the last several generations now. And they put the radios on an M.2 card. So you've got a special M.2 form factor card that's not actually M.2, that is just the physical radios that'll be used for your wireless card, and no other control circuitry or interface circuitry or anything like that. It's strictly just the radios. And the Ethernet part, the networking part, lives on the CPU. It's called CNVI, it's a thing. And that's supported on B360 and H370 motherboards. So a lot of them, although not all of them, will come with wireless, and it's usually the CNVI type wireless. Remains to be seen how good of a wireless solution that is. Still some more testing. I tested an H370 board. The wireless solution there was pretty good. So, just something to keep in mind about differences between the platforms. And so thinking about all the stuff that I just said, hopefully it makes sense to you why you won't see crazy VRM solutions on B360 and H370 motherboards, because that power curve, as you go past 4.3 gigahertz, up to 4.9 gigahertz and beyond, that power curve only just gets more insane. So, 65 watts, 95 watts, 200 watts. I mean, that's not an unusual power curve for these CPUs, because Intel's really pushing it already. So what about the other limitation that you see with the B360 and the H370 motherboards? Memory speed. It's like, oh, well, it's limited to 2666, and it's hard to keep that 6-core CPU fed with 2666. And it's like, well, no, not really. On the Intel platform, memory speeds mostly don't bottleneck the 6-core CPU. That may change if we see an 8-core CPU on this socket, although don't count on it. But 2666 is basically fine. But the timings are not locked down. So even if you've got a DDR4 4000 kit and you want to push this platform, B360, you can just lower your timings. I mean, yeah, the memory's not gonna be clocked at 4000, but effectively it's the same, or it's pretty close to the same, because your 4000 is gonna have higher wait states, so states where the CPU is waiting on the memory to do something. But even though it's only clocked at 2666, the CPU is going to wait less cycles on the memory to do something. So in terms of like how much time passes on the wall clock over there, it's basically the same between 2666 and 4000. There are some edge cases. You can make a little bit of a conversation about latency. The rabbit hole here actually goes really deep, but for practical purposes, it doesn't matter too much that they've locked the memory down to 2666. In fact, I would actually classify it as it lulls Intel fail at segmentation in the market that way. Like it's so pointless. Like they shouldn't have bothered locking down the memory. Although it is a little easier on OEMs. OEMs don't have to do as crazy stuff designing the board to deal with memory that's clocked that high, because board designers do have a lot to worry about when you're dealing with clocks that high. But lowering the latency, not really a big deal. Now, if you're on the fence about choosing this platform and you're worried about Meltdown and Spectre are very serious concerns. They open the door for criminals to basically take control of your entire machine, not just your machine. I mean, they can take control of your machine to the extent that it'll survive a format. That's pretty serious. As of this video, there's nothing like that in the wild, at least that I know of, although I'm sure that intelligence agencies around the world are working on that right now. But I think it'll be fixed. And it's probably going to be a software firmware fix. It's not fixed in silicon, obviously. The next generation CPUs are going to fix the Meltdown and Spectre type problems. You know, even AMD on the competing platform has some similar issues, although as of this video, it doesn't seem like AMD's problems are quite to the extent of Intel's. Intel's problems are actually fairly severe. It's been an engineering problem that's taking them going on 2 years now trying to fix. So you gotta take the benchmarks that you see around the internet with a grain of salt. Our benchmarks, they're gonna have the Meltdown and Spectre patches installed, but you know, it's been a continuous treadmill to try to keep up with all the different versions of the fixes that exist. And the fixes mess with the performance. So you will see a performance regression of, I would say, 10 to 20% by the time the dust settles on this. And you will see a performance regression of around 10% right now with the mitigations that are in place for gaming type workloads or anything that is very IO intensive. Things that are not super IO intensive, it's not as bad. Intel is really pushing vendors to have a lot of the mitigations off by default. I suspect that's because of the performance problems. So that's something else to consider when you're looking at this platform. So depending on what the benchmark numbers are, things like that, I mean, if you're just hanging on by 1 or 2 percentage points for making your decision, keep that in mind. Not to say that I think this is a bad platform or that you shouldn't go with it or anything like that. Not at all. These are fundamental problems of CPU architecture. And the problems even exist in completely different platforms like the IBM Z mainframe system. They've got problems too. So this is a problem that is gonna have to be overcome with additional innovative computer science and computer engineering. So there we are on the 8 to 64 side of things. We were able to get the latency down to 46.5 nanoseconds and our memory bandwidth up to almost 40 gigabytes per second. And that's still limited to that 2666 clock speed. So it plays to pay with your memory timings. It pays to play with your memory timings. It pays to play with your memory timings if you're into that sort of thing. And this is enough of a reduction in latency that you probably will see a little bit of a difference in terms of system performance. Also, oddly, this memory, which I know to be 1T command rate, was coming up as 2T, which should only be at like the 2133, like super compatibility mode. So I'm not sure what that's about. It's also possible to optimize this a little bit further from here. I think it's like 584 clocks on our refresh, which is way too high. It's 584 clocks at the 3600, no, 3400. This is the 3400 kit. It's 584 clocks at the 3400 speed. Need to do a little math to figure out what that is exactly at 2666, but my guess is probably around 500, 480, something like that. So I could even tweak it a little bit from here. This is from just 5 minutes of fiddling with it. So your mileage may vary. I mean, every memory kit is different, every CPU is different. Still, technically, this is an overclock, so bear in mind all those disclaimers. But the next time somebody says a non-K CPU is not overclockable, you know better. So hopefully that was interesting. You learned something. What are we dealing with in terms of specifics on this MSI B360 Gaming Plus? In terms of board layout, well, we've got 2x16 slots. 1x16 slot directly into the CPU. The other by 16 slot is wired PCI Express by 4 directly into the chipset. Our other PCI Express by 1 slots, those are also into the chipset. We've got a single M.2, that's PCI Express 3.0 by 4. That is also wired into the chipset. So if you wanted to run a PCI Express to M.2 adapter and an M.2 on the board, that would totally work fine. If you want to run, Optane on board and an add-in, PCI Express SSD, that'll work fine. If you want to run a SATA hard drive and an add-in something else, all those combinations are completely fine. You can even run a high-speed peripheral like a capture card, like a video capture card or something like that. That's PCI Express by 4. That's connected to the chipset. So basically it's okay. Now you will get a little bit of a bottleneck if you have 2 high-speed devices that are going through the chipset at the same time, because the maximum speed of all of the devices through the chipset is going to top out at 4 gigabytes per second. So if you've got a really fast video capture card and a really fast M.2, potentially there could be a bottleneck there. But unless you're capturing 4K, 60 FPS, 422, 10-bit color depth, you're not gonna run into a bottleneck. I mean, even 4K 30 capturing to this 970 Evo, which has a pretty substantial write speed, it's not gonna bottleneck through the chipset. At the rear I/O, we've got a PS2 combo mouse and keyboard port, which is great for people like me that are rocking the Model M. We've got two USB 2.0 ports, DVI and DisplayPort. So on these boards, sometimes you see DisplayPort, sometimes you see HDMI, sometimes you see a mix. This DisplayPort out will actually do 4K 60 Hertz through the CPU. It's sort of an odd situation with Intel. With HDMI, the boards cannot, in general, the boards cannot do 4K 60 Hertz through HDMI. And the reason for that is because it requires a licensing fee. Yeah, like the HDMI consortium or whoever, somebody demands to be greased, to have their palm greased for 4K 60 Hertz over HDMI. But DisplayPort suffers from no such shenanigans. So boards like this that have DisplayPort will work at 4K 60 Hertz. This is also true on, on the AMD platform. It's like if you get an AMD CPU that's got a built-in graphics card, DisplayPort generally will do 4K 60 Hertz, whereas HDMI will not. Interesting tidbit. Maybe we can raise our torches and pitchforks about that, because that's pretty dumb. I mean, come on. But thankfully, we've got onboard DisplayPort, so 4K 60 Hertz for the onboard GPU if you're gonna do that. Then we've got three USB 3.1, mix of Gen 1, Gen 2, and one is Type-C, so 4. So you get a total of 4 USB 3 ports at the back, 1 Type-C, 3 Type-A. We've also got Intel Gigabit NIC, that's the i219V, and gold-plated audio connectors, 6. It's a 7.1 audio solution. And the audio solution is the Realtek ALC 892. I think I would have liked to have seen a Realtek ALC 1220, but hey, if audio is that important to you, get a USB DAC. You'll be happier anyway. Now, interestingly, we do have an auxiliary PCI Express power input. Not necessary, but it's there in case you're gonna do some crazy stuff. The primary by 16 slot is armored and reinforced. There are 7 4-pin fan headers on this motherboard. 7, one of them is a dedicated water pump header, but what are you gonna do? There are 5 SATA connections on this. The 6th SATA connection is wired through, I think, one of the M.2 slots. They just didn't want to have to deal with, switching the SATA connection between the connector that's on the front edge of the motherboard and the M.2 slot, but hey, whatever, it's fine. 5 SATA connections. Does anybody even have 5 SATA devices anymore? You gotta get a network storage device for that. It does have a Thunderbolt header in case you want to run Thunderbolt, something like that. It's got 2 USB 2.0 headers and a single USB 3.0, that's USB 3.1 Gen 1, the protocol header on the front. In terms of RGB, we do have a single 50/50 LED header, so if RGB is your thing, you can totally do that. One other thing I'll tell you to be on the lookout for on B360 motherboards, some B360 motherboards I've seen only have 2 DIMM slots. This particular one has 4, that's great. I think if you're gonna get a B360 motherboard, you should get one of the ones that's got 4 DIMM slots, just so you can upgrade at some point in the future. This board also has a legacy parallel port header and a legacy serial port header. So if you're still rocking the 25-pin ECP parallel port printer, or you need it for some device or hardware hacking or whatever, you just gotta get the header. It's not in the box. Speaking of the box, what's in the box? You get the header and you get 2 SATA cables. That's pretty much it. So what's the verdict on this board? Well, even though it's a B360, it's still got sort of that gamer enthusiast UEFI. It's got pretty much all the options, at least all the options that you can use in terms of like the hardware. I mean, you can't load the XMP profile or anything like that because of the memory speed limitation, but you can still tweak a lot of settings and still laid out really well. In terms of Linux support, no complaints there. All the hardware works. We're even seeing turbos in Linux up to 4.3 gigahertz on all cores and 4.6 gigahertz on 1 to 2 cores. So everything out of the box with Linux works fine. The Realtek ALC 892 audio codec works fine. The Intel LAN works fine. USB, it's the USB 3.1 Gen 2 B360 chipset. It's okay. I gotta work out some kernel bugs depending on the kernel, like the distribution that you use. But thankfully this motherboard has 2 USB 2.0 ports at the back. I would suggest that you use your mouse and keyboard with those for the least problems. So basically everything is okay on the USB front for Linux as well. In terms of memory support, well, we tried our G.Skill Trident Z memory. We also tried our G.Skill Sniper X memory, and messing with the timings, not a problem. So overall, the verdict on this board, I think This is, I mean, for $100, this is a really, really good value. It's a really solid board. It ticks all the boxes, and you're not gonna be running at that pokey 3.2 gigahertz if you get the 8700. In terms of like, you know, the i5, would the i5 be a better value? Yeah, maybe. I mean, if you're just doing gaming and not really much of anything else, you lose hyper-threading, but not really a lot else. A little bit on the clock speed, but really for gaming, honestly, I don't think it's enough to matter. Having the extra 6 threads, if you're using this as kind of a workstation or something like that, maybe you're looking at upgrading like the, remember the old i7 920s? This would be a good replacement for the i7 920 if you were not planning to overclock or anything like that. If I've gotten anything wrong or you just want to hang out in the forums, you should come to the Level 1 forums. I'm Wendell, I'm signing out, and I'll see you there.